Hey, I'm back with the second screencast on JSLint, a code quality tool. In the previous screencast, I showed you what exactly code quality is and how it is measured and used to write better codes. In this screencast, I'll be focusing mainly on applying an open source code quality tool JSLint on different open source projects written in JavaScript. I'll be showing how to run JSLint on these projects and what different kinds of problems does JSLint catch in your code that if rectified can lead to improvement in the quality of your code. Let's first quickly see what JSLint looks like and how it works. So when we open JSLint.com, we are redirected to the official website for JSLint, which looks like this. The white space which says paste quality code here is the space where we are supposed to paste our source code for quality analysis. You can either paste JavaScript source code or JSON text in this text box. Now let's look at the various options that JSLint gives us. As we saw in my final blog post on JSLint that it follows a certain set of standards like 4 spaces of indentation instead of use of a tab. So whenever we have some code which is following a different set of indentation specifications, we can mention that here in this box so that JSLint does not give errors otherwise. Similarly, we can also specify the maximum characters in a line that the source code follows, because JSLint follows 80, and if it finds something different in the source code, it will throw errors. JSLint also has this feature of specifying the maximum number of errors to be caught. This helps us to solve errors in a modular way by looking at say 10 errors at one point in time. JSLint follows a certain set of standards which it will check in your source code. The various standards that JSLint checks are specified here in the options section, like checking for unused parameters or checking if the source code is missing a use strict statement. Let's talk about one of the standard, messy white spaces. JSLint follows a strict standard for white spaces being used in the source code and will give an error wherever it finds a violation of that standard. But as we know that using extra white spaces will not cause deterioration of the quality of code, we can tweak this parameter so that JSLint won't check our source code for messy white spaces. Now let's paste an open source code and try to analyze its quality using JSLint. This is the list of open source projects that I have selected to analyze using JSLint. Let's go through the full screen Mario application. I have already forked a copy of the source code from GitHub and I have selected the timehandler.js file inside the source directory. Let us copy the source code and then paste it in JSLint to analyze it. So I copied the entire code and I went to my browser and pasted the source code here in the white box. Now when we click this JSLint button, it will analyze the source code that we pasted. As we see that JSLint pointed out many errors related to messy white spaces in our code, which says like unexpected character space. And so JSLint was only capable of scanning 18% of the entire source code. What we can do here is we can use the option that JSLint offers us to ignore messy white spaces. So once I do that, and let's try to run JSLint again on the source code. So we go up and we hit the JSLint button and bingo, it worked. We do not see any space related errors in the list anymore. And also, as we can see, the amount of code scanned by JSLint increased from 18 to 37%. Now we see that there are errors related to the keyword console because JSLint is thinking that console is a variable and not a keyword. Hence it is giving errors that the variable should be defined before it is used. Hence I selected this option which enables JSLint to identify keywords like console alert. Now let's try to run JSLint again on the open source code. When we hit this JSLint button, it checks the source code again. And yes, it surely worked. We cannot see any errors for the keyword console anymore in the list of errors. This happened because now we set the option to detect keywords like console and alert. Hence, when parsing through the source code, JSLint knew that console is not a variable used, but it is a predefined keyword. Hence, it stopped giving us errors regarding that. JSLint also gives us errors on where keywords. These are not errors, But JSLint points out so that we can combine various variable declarations into one statement. This is basically done to optimize our code. Now let's try another file from the same project. I've selected eventhandler.js file, and let's copy paste its source code into JSLint in the white space. So we have pasted the source code to be analyzed in JSLint. Now let's hit the JSLint button. On the first run, we get the same set of errors like different standards for indentation, console is a variable instead of a keyword, and hence it gives errors. So let's try to tweak all the same parameters and see if the number of errors get reduced. So I tweak the messy white space and I say that detect keywords like console, and let's try to run JSLint again. Yes, so the number of errors have reduced. What can we infer from these results? We can clearly say that this project does not follow those specific set of standards that JSLint checks in a source code. It follows different standards for indentation, and it declares variables as and when needed, and not all of them together. Hence we can say that this source code does not have a very good code quality according to JSLint. But now let us check if it works, and even if the quality is not up to the mark. Let's open the application. So we open the index.html file and we see, yeah, the application works completely fine. Hence we can say that JSLint gives you suggestions to improve your code quality even if the code works fine. JSLint scrutinizes your code for errors that a browser might miss, because browsers focus on the working of your application and has nothing to do with the code quality. Now let's analyze another project from my list of open source projects, the Ghost. Ghost is basically just a blogging platform written in JavaScript. So I already forked a copy from GitHub and I decided to analyze the ghost.js file. I select all of its source code and paste it in JSLint, and yes, that's done. And we modified the parameters back to the normal state, default state, so that JSLint scrutinizes the source code perfectly. So when we hit the JSLint button, JSLint again gave a number of errors along with the location and a small description of the errors. Now let's look at the errors and try to understand what they mean. As we can see that this source code is missing the useStrict statement. It is a good practice to have the useStrict statement in the source code, but the code will work perfectly fine even if you do not have it. JSLint gives you an option to ignore this statement and scan the source code so that it does not throw errors when it comes across that missing statement. So let's run JSLint again on the source code. So let's click the JSLint button. As we can see, the number of errors have been reduced, and there are only two major kinds of errors in the source code. Now let's select another file from the same project and analyze it using JSLint. So I selected the server.js file, I copied all of its content and I pasted it inside the text box. Let's make all the options to its default behavior. So JSLint is not partial, and now we hit the JSLint button to analyze it. Let us look at the errors that JSLint pointed out. Again we see that there are only a few errors like missing useStrict statements, again using a keyword which is thought as a variable, etc. So let us set the option to ignore the missing useStrict statement and run JSLint on it again. So we make the tolerate the missing useStrict pragma and hit the JSLint button again. Now we see another kind of error regarding the to-do comments right over here. Yeah. So before the third iteration, let us select that option to tolerate the to-do comments in the source code. Once we have selected that option, which I did right now, let's try to run JSLint again on the source code. As we can see that the to-do error is not thrown by JSLint again. This implies that As we can see, the number of errors have been reduced and there are only two main kinds of errors. This implies that the Ghost project has a better code quality. Thus, after going through the results of running JSLint on both the open source projects, Ghost and Fullscreen Mario, I can say that the Ghost project follows the quality conventions to a greater extent as compared to the Fullscreen Mario application. This is the step-by-step approach that we should follow to improve the quality of our code. We should write our code and then try running JSLint on it. Suppose it gave errors regarding the use strict statements. We should include that statement wherever needed, and after that we should run JSLint again on our code. Hence, after following this step-by-step approach to improve the quality of our code, we'll have a very strong code base for our application. And it is only if we have a strong code base will our application run successfully over a long period of time. This is the last screencast in the series, and the transcript for this screencast can be found on bnsha.wordpress.ncsu.edu.